Alright, okay, let's start the lesson. Okay, so today we're gonna be learning about angles. And do you know angles? So yes, I do. We can find angles in all kinds of things in our life. For example, you can find angles in all the items above. We can find angles in this milk box. We can find it in the scissors. We can find it in the rulers, and then we can also find it in the clock as well as house. Okay, so we can find it basically everywhere in just everyday items. So for example, with this notebook, I have angles here and angles here, okay? You can look around. You can find angles basically just, everywhere. If you want to give me some examples, you can type in the chat box as well. Okay, so we see a right angle here, and then we see angle here. I think you guys get the idea, right? Yeah, paper, iPad, that's right. So what interesting knowledge can we learn about angles in mathematics? Let's find out together. Okay, so the definition of an angle is the figure composed of two rays from one common endpoint. Do you guys remember when we talked about rays last time? So just to refresh your memory, a ray has one endpoint, and then it is a straight line going in one direction, okay? So the angle is made up of two rays, and these two rays are called the sides of the angle. Okay, both sides of the angle must be straight, so they can't be a curved line. They have to be straight lines. And the common endpoint that these two rays meet is called the vertex of the angle, okay? So for example, looking at this picture below, we have the vertex here, which is the endpoint. Just let me draw it here. So the vertex here is the endpoint where the two lines meet, yeah? And then we have the two rays here forming the two sides of the angle. Yes, you can have a degree at the vertex, like 90 degrees. That will make it a right angle, okay? Or we can have other measurements. So we're gonna start by having a warm-up question. Which of the following figures are angles? Remember, angles is composed of two rays having a common endpoint called the vertex. So I'm gonna go through each of them, and I want you to help me out. So if you could type in the chat box whether you think this is an angle or if it's not an angle, that would be great, okay? So the first one, do you guys think it's an angle? Yep, good job. What about the second one? No, okay, that's right. It's not an angle because we have curved lines, okay? And what about the third one? Yep, that's an angle. What about the fourth one? Yep. Why is fourth one not an angle? Because they don't meet up. They don't share a common endpoint, so there's no vertex in here. Okay, what about the last one? Good job. Okay, so we're gonna move on. We're gonna have a first ask question, okay? How many angles are there in the figures below? So I want you to count with me how many angles you can see in the figures below. So remember, each angle has two rays and one vertex. And we're gonna look at the first one here. So we can see an angle here, right? We have side 1, side 2, and then the vertex here forming the first angle. And then we can also see another angle here. So the first one has two angles. And the second one, we can see one here, one here, one here, one here. And that gives us, yep, good job, 4 angles. And the third one, we can see one here, and one here, right? So we have 3 angles for the third one. Does that all make sense? Or am I going through this too fast? Okay, that's good. So we're gonna go to our first act question, okay? So how many angles does each figure have? I'm just gonna close the chat box for a minute. So we're gonna have three shapes down here. We have a pentagon, a circle, and a triangle. And I want you guys to find how many angles does each shape have. Okay, and I want you to choose the answer in the selector below. So I'll give you guys, I think this question is okay. We'll set a 2-minute timer starting from now and we'll see how you go, okay? Okay, very good. I see you guys on the right track, okay? Just keep doing that. You have just over 1 minute left. And if you're a little confused, the answer, the three numbers are in the order corresponding to the order of the shapes. Okay, time's up. Let's see. So the correct answer for this question is D. Would anyone like to come up stage and explain it to us? Hi, Keaton.
I just wanted to say that
Yeah.
I came late. I came late because I had my bath, and then I don't know what we're doing, and I want to know who got 100%.
Sorry, can you repeat that again? I couldn't hear you.
So I came late.
Yeah?
I came late because I had my bath.
Oh, okay, that's okay. Do you want to hop off stage and then we'll get someone else to help us out? Do you want to do that?
Maybe.
Yeah. Because you said you came in late, so you don't know what we were doing, right?
Yeah, but I know we're doing angles, and I know what's angle.
Okay. Do you want to give it a try?
Yeah.
Sure. I think you know what I think will be easier. I'll give you the drawing function. You can draw the angles for us, okay?
Okay.
Yeah. Sorry, that's a angle that you draw, right?
Uh-huh.
Yeah, so that is the correct definition of an angle. We have a vertex and we have two rays that joining at the same endpoint, which is the vertex. Okay, but I think for this question, because you came in late, we have to find out the answer for the question. Do you want me to go through it?
Yeah.
Okay, sure. I'm just gonna pop you off stage, and thank you for coming up stage. So I'm just gonna go through this question, and then we'll have someone upstage for the next one. So for the first shape, we can see one angle here, another one here, another one here. So we have 5 angles for the first shape. Oh, you guys really want to come on stage? Okay, let's see. Put your hand up if you want to come on stage. Hi, Xinyan.
Hi.
Hi, do you want to help us out with the question? Since I already started on the first one, you want to start from the circle?
Yes.
Okay, I'll give you the drawing function, and you can write it in the bracket.
It has no angles because it is not straight.
Yeah, it's not straight. Very good.
This has 3 angles because it has 3 corners.
And what's another name for the corner? We can also call them vertex, right? Okay, good job. So you chose that's 5, 0, and 3 angles for each figure. So it will be D. Is that correct? Okay, thank you so much. Here's your trophy. Did everyone understood the question? So we're gonna move on. Okay, thank you again, Xinyang. I'm just gonna pop you off stage, and we're gonna move on. So since we already know the angle, let's learn about the types of angles. Okay, how can we classify angles according to the angle measures? So we have types of angles. There's 3 types: the right angle, acute angles, and obtuse angles. A right angle is a special angle. The measure of a right angle is 90 degrees. Okay, 90 is actually a very special number when we talk about angles. So really just keep that number in your head. Okay, 90 degrees. A right angle is denoted as this little symbol here. And the first figure is a right angle. So to make this clearer, I'm actually going to borrow a tool. I'm going to bring up a ruler that will help us to see this a bit easier. So you see, in this ruler, we form a right angle here. Okay, and we're just going to move it against the shapes to see. Yeah, I think that fits pretty well, don't you think? So we will say the first one is a right angle. Okay, because this angle is 90 degrees here. What about the second one? I don't think the second one looks like a right angle. Do you guys think? No, yeah. And the third one also doesn't look like a right angle. No. Okay. So an angle that is greater than 0 degrees and less than 90 degrees, which would be the second one here, because you see it's not quite 90 degrees, it's less than that. So that satisfies being greater than 0 degrees and less than 90 degrees. So we will call it an acute angle. An angle that is greater than 90 degrees and less than 180 degrees is an obtuse angle, okay? So you can see that this one is greater than 90 degrees, but it's less than 180 degrees. So this one, the third one, will be an obtuse angle. Does that make sense, everybody? Yeah, okay. So according to the angle measurements, we can find an acute angle, which is less than 90 degrees, is smaller than a right angle. I'm just going to write it here. So acute angle, that's less than 90 degrees, is smaller than a right angle, which is equal to 90 degrees, which is smaller than an obtuse angle, which is bigger than 90 degrees. Okay, so you can see we can basically classify it based on whether if it's smaller, equal to, or larger than 90 degrees. This is why I said 90 degrees is a very special number when we talk about angles, okay? So how do you decide which type of angle is a given angle? You can use a set square to decide the type of angle is shown. Okay, so for example, the square would have a right angle, like this one. This is a triangle, it's not quite a square, but we also have a right angle here, okay? So we can use this to see if it's a right angle, acute angle, or obtuse angle, okay? Just like we did before. Uh, any questions? Do you have a question, Lois? No? Okay. So we're gonna move on. Let's do another question. Okay, how many right angles, acute angles, and obtuse angles are there in the figures below? Okay, and we're gonna choose from one of the options here. So let's first analyze the figures one by one. Okay, let's bring out our old friend, the ruler here, and we're gonna let it help us to figure out. Okay, so the first one, what type of angles do you guys think this is? Anyone, anyone want to help me out? Yeah, good job. Okay, so that's an obtuse angle. Let's just label it so it's easier for us to keep track. I'm gonna just put O here for obtuse. And what about the second one? What do you think the second one is? Yeah, the second one is a right angle. I'm gonna put a R. What about this one? The third one. Yes, that's an acute angle because it's, you can see it's obviously less than 90 degrees. Yeah. What about this one? Okay, let's tilt it a little bit. Okay. What do you think this is? Acute, yes. Okay, so we have another acute angle here. And what about this one? Let's here. That's that's bigger than 90 degrees, isn't it? So yeah, it's obtuse. Just gonna write it here. And what about the last one? Anybody want to take a guess? That seems like a right angle to me, doesn't it? Yeah. So let's count it. How many right angles do we have? We have one, two right angles. So two right angles. And we have one, two acute angles. And one, two obtuse angles. So which one do you think it is? Which answer do you think fits our? Yep. So B will be the answer for this one. Okay. So I think this one is quite straightforward, and I think you guys are so smart. You can even use it without a ruler, don't you think? So I'm gonna give you something to try. An act question, okay? So what I want you to do in this question is I want you to analyze the figures one by one, like we just did before, okay? Just gonna look at it separately, one by one. And I want you to tell me how many of these shapes have at least one right angle, okay? So as long as it has one right angle, then that shape has at least one right angle. Does that make sense? So it doesn't matter if it has one, two, three, four. If it has one right angle, then that satisfies our question. And I want you to see how many of those shapes satisfies the right angle criteria. Okay, so again, I'm gonna give you guys 2 minutes, starting from now. I'm gonna close the chat. Okay, we're gonna stop there because I see all of you have chosen an answer already. So we're gonna stop the answering. Okay, the right answer for this question is B. Just gonna give a reward, a trophy out for all of you that chose the right answer. So, and would anyone like to come up stage? So if you've chosen the right answer. Hi, Misha. Hi. Do you
Hi.
want to help us out? Do you want to draw on the diagrams here?
Yeah. Yeah. But I just don't understand. I don't understand though.
Um, do you want to get someone else up on stage so they can help us to figure out the question together?
Yeah.
Yeah. Okay. Does anyone else want to come up stage? Okay. Let's see.
What?
I'm just gonna hop you off. Give me 1 second.
Is it like, can we do like some? Okay.
Hi, Justin. Hi. Do you want to help us do the question here? Is your mic on? Um, okay, let's try someone else, okay? Hi, Ella. Can you please turn on your mic?
Okay.
Hi, do you want to help us do the question here? I'll let you draw. Yeah.
So, A doesn't have any right angles,
Yeah.
and B doesn't have, and B doesn't have any, but C has one over here,
Yeah.
um over here
Yeah.
has a right angle,
Mm-hmm.
and this one also has one.
Yeah.
Well, that one has two actually, and this one also has another one here.
Okay.
So altogether, there are three shapes that have at least one right angle. The answer is B.
Okay. Good. Very good. Thank you. So thank you for coming up stage. Um, what I'm gonna do actually is that I'm gonna count the angles for you guys, okay? Just so that you guys really get an idea. So for the first one, we actually don't have any right angles, right? So we have an obtuse angle here, and an acute angle here, and an acute angle there. Yep. And this one is bigger than 90 degrees, so we have another obtuse angle. And so is this one, obtuse angle, okay? Acute angle, acute angle. So we have another acute angle here, acute, and this one's a right angle, okay? So we're gonna draw it with that, do you guys remember the special symbol here? Instead of pointing out the angle like a half circle, for right angle, they have a special symbol. It's like a perpendicular lines together, okay? And then for this one, right angle, right angle, right angle, right angle. And this one's the obtuse angle and acute angle. Have a right angle here and a right angle there. Does that all make sense? Yep. Okay. Which part of it doesn't make sense? Misha and Teresa. Do you guys have any questions about it? Yeah, just type it in the chat and I'll try to answer for you, okay? Okay, you came late. Okay, so I'm just gonna give you a really quick recap. What we talked about angles, and we've been counting angles and identifying what type of angles they are. So an angle has two rays, and they share a common endpoint, which is the vertex. And the two rays are sides of an angle, okay? And you have to satisfy this to be called an angle. And for the numerous angles that we can see in our everyday life, we can classify them into three types. Okay, we have the acute angle, which is what A here means. So I just didn't write the full name because it would take a lot more time. So A is for acute. And then we also have the right angle, which I wrote as a little R there. Or they have the special symbol of the two perpendicular line. And we also have the obtuse angle. So how can we tell whether an angle is acute, right, or obtuse? Acute angle is bigger than 0 degrees and smaller than 90 degrees. Okay? Right angle is equal to 90 degrees, and obtuse angle is larger than 90 degrees and smaller than 180 degrees. Okay, does that make sense? So the AO, I just wrote it to save time, okay? A for acute, O for obtuse. Okay, so let's move on. We have learned acute angles, right angles, and obtuse angles. Now let's have a look at an interesting practical question next. So in this question, make one cut to the square below. How many angles does the remaining figure contain? Okay, so we're gonna cut the shape once, and we're gonna see how many angles does the remaining figure contain. So step one, we're gonna analyze the situation. We're gonna decide where the cut is made. So we're gonna assume that the first option is that we cut it from a vertex. Okay, so we have four vertices here, or vertices here, 1, 2, 3, 4, right? So let's just choose like a random vertex. We're gonna say we cut from this vertex. If we're gonna cut from this vertex, let's say we cut it like that, okay? So how many angles do we have left? So this one is very similar to this one below. Actually, because it's gonna be the same, I'm just gonna draw like that so it's easier for you guys to see. So from this vertex to a side, okay? So we don't pass through the vertex here. We're gonna cut it through a side. And let's assume we're gonna cut away this one. So we're gonna count how many are left on this shape. We have one angle, two angles, three angles, and a little one here as well, four angles, just like this one, okay? So we can have four angles left. What about if we don't cut it from the vertex? Sorry, what if about we don't cut from the vertex to a side? We cut through the vertex and the opposite vertex. It's not a very straight line. So we cut it like that. So in either case, we would have one, two, three angles left. Is that correct? Yeah. So we're gonna have three angles left. Or what about if we just don't go through the vertex at all? What if we cut from side to a side? And let's say have one angle here, a right angle here, right angle here, right angle here, and another angle here. That would be how many angles? Five angles. And that is pretty much all of the options that we have in terms of varying angles to be left after we cut it once. So for this question, after deciding whether the cut is going to be made from the vertex and whether it will be passing through another vertex, or if it will pass through one side, or if the cut's going to pass through two sides, we can figure out that there are three possible options. So we have either 3 angles, 4 angles, or 5 angles left. Does that make sense? Yeah. So back then, we had a look at whether what would happen if we cut it from the vertex, and we figured out that we would either have 3 angles left or 4 angles left. And now this picture just shows that what if we cut through one side to another side? And you see, no matter how we do it, we're gonna either have 4 angles, 5 angles, or 3 angles here. So the answer for this question is that we either have 3 angles remaining, 4 angles remaining, or 5 angles remaining. Okay? So in summary, after cutting a figure once, how many angles does the remaining figure have? So what we're gonna do in these type of question is that we're gonna analyze the situation where the cut is made from a vertex. Okay, so that is our scenario 1. And then we're going to analyze the situation where the cut is made from one side to another side. And then we're going to find the answer. Okay? So I'll give you guys a question to try. Did that make sense, everyone? I can see a lot of question marks. Is it about the question that we just went through? Okay, no, as in you have some questions, right? Okay, let's go through this one again. So what we do in these type of questions is that, um, actually, I'm going to go back to this question so you can see it more clearly. What we do first for step 1 is that we're gonna assume that there are 2 scenarios, eh? So for example, like 2 cases or 2 scenarios. So number 1, what we're gonna do is that the cut is gonna be made from the vertex. So what type of cuts can we make if it has to be from a vertex? We could either go from a vertex to vertex, which is like this figure here, or we could cut from a vertex to a side, okay? So the second part doesn't go through another vertex. So that would look like something, that would look something like this, or it could look something like that. Yeah, you can choose which side you want to use, but really there's not like a lot of option, because if you really look at it, so we're talking about the cut that we make through one vertex across to another side, right? You can't cross this side because that would be a straight line. That's not really a cut, right? So we could either pass through this side or we could pass through this side. So we can only have 2 options here. Yeah? And then another one is that we cut from one vertex across to the other vertex. So A, B, C, we can have 3 types of cuts, just like the ones shown below. And then for each type, you could either have 4 angles, 3 angles, or 3 angles. Okay, and then what we're gonna do is that we're gonna look at the second scenario. So what we just went through is that when the cut is made from a vertex, right? Doesn't matter if it's gonna pass through another vertex or across through a side. Now the second scenario is that the situation is where the cut is made from one side to another side. So it doesn't pass through any vertex at all. So we could either, if we start from this side, we could go from the side of here or the side of here, right? And in those scenarios, you could have 3 angles, or we could have 5 angles, or 4 angles. Does that make more sense? So this is what we meant by analyze the situation where the cut is made from a vertex and where the cut is made from one side to another side. And then you're gonna find the answers after you you draw it all out, listed out all the possible possibilities. Okay. So okay, if no one has any questions, we're gonna move on. If that's okay. Okay. So we have another act question. So in this question, they want you to make one cut to the triangle below. How many angles does the remaining figure have? So remember this one, the step one, what we're gonna do is that we're gonna analyze a situation where the cut is made from a vertex, okay? And then go back a step. And then you're gonna analyze a situation where the cut is made from a side. So I'm gonna give you guys 3 minutes, starting from now, okay? And just want you to remember for this question, you can have multiple answers because depending on how the cut is designed, we could have different number of angles left. Okay? Okay. See a lot of answers. So just keep going. You have about a minute left, okay? All right, time's up. Copy your answers. I'm just gonna stop the answers here. Okay. So for this question, if you chose both B and C, so 3 and 4, you have the right answer. Okay. So I'm gonna hand out some trophies. Congratulations. Does anyone want to come up stage who has got the right answers? Hi, Lois. Can you please turn on your mic? There you go.
I
Do you want to help us? Do you want to show us how you chose the right answers for this one?
I just.
Do you want to draw on it? There you go.
I just stand.
Yeah?
I just don't understand.
Oh, you don't understand. Okay. How about we get someone upstage and hopefully they can help us out to figure out what this question is about. What do you say?
Okay.
Yeah? Okay. Okay. Would anyone like to come upstage that has got the right answers and want to explain it to us? Or should I go through this question for you guys? Okay. I might just go through this question for you guys. So what we're gonna do first is that, remember when we did the summary, the step one is to analyze the situation where the cut is, okay. So if the cut is made from a vertex, I'm just gonna draw it on the figure as well. So we're gonna go through this vertex and then go through here. Okay. So in this case, we only have one option because it has to go through a vertex and a side. It can't go through, remember the square question that we did? It could go through two vertices because in that case, we actually have another vertex that we can go through. But in this case, if we go through this vertex, it will be parallel to the side. That's not really a cut. And similar with this side as well. So the only option that we have is to go through this vertex here and this side here. Okay. If that's the case, we're gonna have three angles, just like drawn below here, right? So we're gonna have three angles. What about the second scenario if the cut is made from one side to another side? We can have these two scenarios. So you see for this one, it's from one side to another side, yeah? And that divides the triangle into two different shapes, right? For the one on the bottom, we could have four angles. And for the one on the top, we can have three angles. So how many angles does the remaining figure have? We only have two options, right? We could either have three angles remaining or four angles remaining. So that will make B and C the correct answers here. Does that make sense? Yeah. Any questions about it? I know this one is a little bit confusing because you have to draw out each of the scenarios yourself, and that way you can find out how many angles there's left for each shape. Oh, Iris, make sure you submit it next time, okay? So check when the timer is about to end, and then make sure to submit it before the timer finishes. Okay, so which part of it do you guys have trouble understanding? I'm gonna go through that again. So just tell me which part you're not quite sure. Okay, why don't we go through this again? So remember back here, when we're doing the cutting figure questions, we have to follow the steps, right? The first step is that we're gonna cut it through a vertex. So the cut is gonna start from a vertex, okay? And then the second the second step is that we're gonna analyze the situation where the cut is made from one side to another side. Why do we do two separate steps? Because we have different ways of cutting the shape. That's why we have to do it in separate steps, so we know that for each scenario, how many angles you're gonna have left. Okay? So just like we done here, step one is that we're gonna see what would happen if we make a cut through a vertex. So you see how it started from a vertex here, and then pass through another side. And if that's the cut, we're gonna have three angles. Yeah? So that makes B an answer. What about for the second step? The second step, we're going to see what would happen if the cut is made from one side to another side. So for example, it will look something like these two shapes here. So if that's the case, we could either have 4 angles or we could have 3 angles. That means B or C are the right answers. Okay, good. Okay, that's so good you get it now, Olivia. Who else had the questions before? Does that make more sense? Yeah? Okay, good. So we're gonna do one advanced question and then we're gonna have a break time, okay? So for this question, we're gonna look at the cuboid below and answer the questions. So this is a cuboid here. Here's a cuboid here. We have 4 questions that we have to answer. Okay, the first question is how many faces does a cuboid have? So the faces is the surface of the shape. Okay, so for example, let me give you an example. If I have a box here, this will be a face, this will be a face, this will be a face, another face. Do you see what I mean? So these are the surfaces of the shape. And if we're looking at this cuboid here, can we count how many faces we have? So we have the one at the front here, right? The one that we can see, the one that we can see straight on. So this is one face, and the one on the side is another face. And then we can see the one on the very back. So if we imagine we're going to go across, go around to the back of the shape, that's going to be our third face that we're going to see. And the one on the left there, the face on the left is the fourth one, okay? And we have another face on the top and another one on the bottom. So this shape has 6 faces. Does that make sense? Yeah. And what is the shape of each face? What do you think these faces, like what do you think their shape is? What would you call these? Is that a circle? Is it a triangle? How would you call it? Yeah, rectangle. Okay. So we have the rectangles here. Or the top, so the phase 5 and phase 6, they're actually squares. But since square is a type of rectangle, so we could just say they're rectangles. And how many angles are there on each face? So I'm going to pull out a face so it's easier for you to see. So assume this is a face. How many angles do we have? 1, 2, 3, 4. And they're all right angles, right? So that's 4 angles per face. And if we look at the next question, how many right angles does this cuboid have? So we just figured out that there's 4 faces per, 4 angles per face. And how many faces do we have? 6 faces. So if we have 4 per face and we have 6 faces, we're going to have 24 right angles in this cuboid. Does that make sense, everyone? It's a little bit different from the questions that we've done before. It's more application based, so it's a little more interesting. Okay? So if there's no questions about this, we're gonna hop on to the break time, okay? Yep. Okay, so it's break time for now. I'll just answer your question, Austin. Why is it rectangles? So the question, just give me 1 second. I'm gonna pop up a timer of 5 minutes for our break time, starting from now. And we'll be back in 5 minutes. So, Austin, I'm gonna answer your question now. So why is it rectangle? Because this question asked, what is the shape of each face? And you see this face here, this surface, it's a rectangle shape. That's why the answer is rectangle. Does that make sense? Okay, good. Yeah, that's right. They're square as well, Riley. So we have the top surface and the bottom surface, they're squares. But because square is a special type of rectangle, so it kind of belongs in the rectangle category. So we would just say the shape of each face is rectangle. But if you say rectangle and square, I would say that's the right answer as well. Okay. Oh, good job, Fiona. So you're in the blue team. What's the name of the blue team? Just blue? Okay, I remember I was in the red team, and the team name I think was Lawson. So, did you participate in any competitions in the athletics carnival? Okay. Oh, how did you go, Isaac? How was the chess competition? Yeah, 6 rounds. Okay. Oh, okay. That's okay. I think you definitely do better next time. It's I think even though I don't really play chess, but I think chess you need to build it upon experiences, right? So the more you play, I'm sure the better you'll get. All right, okay, I'm gonna hand out the excellent homework trophies. Good job, Alicia. Good job, Austin. Good job. Good job, Chantal. Molly. Fernando. Nina. Liza. Dave. Junjun. Eden. Lou. We have Lori. Michelle. Moran. Olivia. And Olivia. Oscar. Oscar. All right, so that's the end of our break time. Just gonna finish this. Ryder, Sophia, Sophie, Teresa, Xavier, and Jojo. Okay, good job, guys. So we're gonna go back to our lesson, okay? Everyone ready? So we've learned the definition of angles and the 3 types of angles. Next, let's count the number of angles. So we're going to do this question together. How many angles does each figure have? So there are 2 figures here. We're going to look at A first, okay? So what we're going to do first is that we're going to use the listing method. Do you remember listing for when we did the combination lesson? Yeah? We're going to find the number of angles with no ray inside. This is very similar to our last questions as well. Remember counting the number of rays, the number of lines inside the shape? Okay? And then, so we're going to do that first. So what does it mean by no ray inside? It means that we're going to look at these like small angles that there's no ray in between them, okay? So there's no ray in between the two sides of that angle. So we have one here, and then we have another one here. So that is two angles, right? That have no ray inside. And then what we're going to do is that we're going to look at the number of angles with one ray inside. So what that will look like is that we're going to have a ray in between the two sides of the angle that we're going to draw out. So I would say that we can draw one looking like that. It's a little bit, it's not really straight, but you see what I mean, right? So in this angle, between the two sides, we have one ray in between. And that's another angle. So we use 1 plus 2, we have 3 angles in this figure. Does that make any sense? Yeah? Okay. Now we're going to have a look at B. So we're going to use the same method to find out how many angles there are in the second figure, the figure B, with no rays inside. So we're going to look at the small angles without any rays in between. So we have one here, one here. Actually, I think that's a little bit confusing, so I'm just going to draw like this. So we have one here, right? And then one here, and another one there. Does that make sense, the way that I draw it? Yeah? Okay. It just makes it, less messy. So, and what this little thingy means, it's a symbol that we use to describe an angle that's enclosed by two sides. Okay? So we have 3 angles with no rays inside. And I think it will be more clear if you look at the pictures here. So that's a first angle, that's a second angle, that's a third angle. Okay? And then what we're going to do is that we're going to find the number of angles with one ray inside. So the first one I will say is this one, okay? This angle here. And the second one I will say is this angle. Okay, so if you draw it out, it will look like this. So we have 2 angles with one ray inside. And we have another possibility is that we look at the number of angles with 2 rays inside, which is the biggest angle that we have in this entire figure. It would be this one, wouldn't it? With 2 rays enclosed inside the 2 sides. Does that make sense? So another one from here. And how many total number of angles can we see from figure B? 6. Yes, good job. So 6 would be our answer. Okay. Yeah. So you guys want to know what the answer for A is? A is 3. Okay, because we have one angle here, another angle there, and then the big one that encloses the ring on the inside, so 3. Does that make sense? So what we just did, like that kind of question that we just went through, what you can do is that you count by classifying it. So what do we mean by classify is that we classify into types. So the first one we're going to see the angles with no rays inside. So this would be like the small angles. They don't have any rays in between them. Okay, so we're going to count how many of those there are in the figure. And then we're going to move on to a bigger one. So the larger angle, that would have one or more rays inside. This will depend on how many lines there are at the same vertex, because um, unless we know how many rays there are, we won't be able to know what this number will go up to. So we just say that we move on to counting the larger angles with one or more rays inside. Okay, we count them in turn. So for example, like the last one, like the figure B here, we were counting the angles with one ray inside, and then we counted the angle with two rays inside. So you just go up like that. If it's an even bigger one, you could say how many angles with three rays inside. But the important thing is that you do it systematically, okay? So you do it by order with one race, two race, three race inside. If you go up like that, it's very hard for you to mess up. Otherwise, it can be a little bit confusing and it could be hard to keep track of, okay? That's why we want to move up to the size. So move up to larger angles. And then we're going to add up and obtain the total number of angles. So I'm going to give you guys an act question to try. We'll give you guys 3 minutes for this question, starting from now. And I want you to, following the method that we just talked about, to tell me how many angles does the figure below have. Okay, I see a lot of right answers. I think you guys are on the right track. Just keep going. Remember to go up from small angles with no rays in between, and then to larger angles. I think most of you have put in your answers. Just gonna give you 10 more seconds. All right, everyone has put down an answer. So we're gonna stop here. The correct answer for this question is B. So congratulations to those that answered B. Does anyone want to come up stage and help us with the question? So please raise your hand up if you chose the right answer. Hi, Jake.
Hi.
Hi, do you want to help us with the question here? I'll give you the
Okay.
drawing.
So, how I done it is first pretend that nothing is here. So, and then now, first of all, we count the ones that have no rays. So, for example, this one
Mm-hmm.
and this one,
Yeah.
and that makes two. And then now we count the one with a ray. So like this one.
Yeah.
And then now we'll just make this one appear like now. And then now we'll now do that because um when you do, like, for example, like this, it doesn't work because it's not connecting to each other.
Yeah, there's no vertex, right? So that's not an angle.
Yeah. And that means 2 plus 1 is 4.
Okay, so we have the right answer B here. Thank you so much. I think you explained that so well. It was really clear. So here's a trophy. Thanks for that. I'm just gonna hop you off stage. Now, does anyone, I'm gonna open the chat room. Anyone have any questions about what we went through? No? Pretty straightforward, isn't it? What question do you have, Teresa? Could you please, and Keaton, can you guys please type it in the chat box, and I'll try to answer them. Yeah. Anyone had any questions? Teresa and Keaton? No? Okay, so Teresa, so what we did is that we find the number of angles by listing them, by classifying them. Okay, so first we look at the ones with no rays inside, so the small angles, like this one here. Okay, and also this one over here, this one over here. You see, these are the angles that doesn't have any ray in between. So inside that classification, we found 3 angles. Okay, and then what we're going to do is that we're going to find the number of angles with 1 ray inside, which is something like this. And that's the only one inside this figure. So that's another angle that we had. And we have 3 plus 1, which is 4. Or you could do what Jake did. Jake, look at this angle separately, because it's kind of not within the certain vertex here. So he looked at it separately, which is also a valid way because we got the same answer here. Okay, nice. Okay, so let's have a look at a more complicated problem that requires angle counting. So this question, how many angles does the figure below have? This one looks a lot more harder than what we have done so far, right? But I promise you it's not that hard. We just gotta look at it separately. So remember when we were counting the number of angles inside something that looks like this? We had questions like this, right? And we were counting how many angles were inside there. What we did was that we used the listening method and we counted from no rays inside to however many rays inside. So what we're gonna do here is very similar, but first we're gonna find the vertexes or the vertices, okay? So we have one vertex here. Let me draw it out. We have one vertex here, another one here, another one here, here, here. So these are all the possible spots that we can form an angle from. Okay, and we're just going to go through them one by one. First, we're going to see the number of angles with no rays inside. So we have one here, another one here, 3, 4, 5, 6, 7, 8, 9. Okay, so for the angles with no rays inside, we have 9 angles. Okay, and then what we're going to do next is that we're going to find the number of angles with 1 ray inside. So then what we're going to do is that we're going to find how many angles have 1 ray inside. And it's going to look something like that. So I'll just draw it with you guys. We're going to have one here. You see, this one has 1 ray inside. Another one here with 1 ray inside. One here with 1 ray inside. And I'll just change the color. And another one here with 1 ray inside. So how many is that? 4 angles with 1 ray inside. Is that correct? And then we can also find the number of angles with 2 rays inside. So where are we gonna find that? We obviously this part only has one ray, okay? So the only place that we would find an angle with two rays inside is here. And that's the only angle in the entire figure that satisfies that. Okay? So if we count the number of angles with two rays inside, we're only gonna have one. And we're gonna use 9 plus 4 plus 1. Why do we do that? Because that's the last step that we're gonna do, which is find the total number of angles. And that gives us a total of, yeah, good job, 14. So we have D is a correct answer here. We're going to have 14 angles in the figure below here. Okay, does that make sense, guys? Yes? Okay, do you think you guys are ready to do a question by yourself? Okay, let's move on. So in this question, I will give you guys 3 minutes and I want you to figure out how many angles does the figure below have. So remember, it will be a lot easier because it's quite a complicated shape. So it'll be a lot easier if you do it systematically, do it step by step like we just did, okay? Starting from the angles with no rays inside and then work your way up. Okay, so it's 3 minutes starting from now.